start with chapter 7, kinetic model of matter. Okay, in terms of states of matter, in primary school you have learned what's the difference between solid, liquid and gas. But now in secondary school, right, it's more about learning in terms of the microscopic view. Okay, so in primary school you learn that for solid it has fixed shape, fixed volume, not compressible and high density. So for liquid, right, it does not have a fixed shape, so there is no fixed shape, but there is a fixed volume. Okay, liquids in general, right, they are not compressible, but I need to create a caveat. But once you go to higher education, this thing may not hold true. Okay, liquid in general, they have medium density, so they are usually less dense than solid, but it's not always true. So like for example, liquid like styrofoam is a solid, but it has a high density. Okay, for gas on the other hand, it has no fixed shape, it has no fixed volume, and it is compressible, and it usually has very low density. Okay, so usually air rises, liquid sinks. Okay, in terms of distance between particles, the distance between particles are, what do I mean by solid? It is like this. You have learned this before in lower sec, that solid is generally like this. They are held together very closely in a regular pattern. But liquid on the other hand, they are not as close as solid, but they are in an irregular pattern. So what do I mean by this? If like for example, I have a container like this, my liquid particles are all around. They are not in a regular pattern, but in an irregular pattern. Gas on the other hand, they are very far apart and irregular pattern also. So if let's say I have a box of air, you just need to draw your air particles randomly. They are all very far apart. Okay. Whereas with regards to the forces of attraction, we need to explain that for solid, they have very strong attractive forces that hold them in fixed position. Liquid on the other hand, they have the word strong. The word very is now missing. Strong forces, strong attractive forces. Okay, this one is irregular pattern. Okay, so like what I said earlier down here, that the particles, they are all irregularly arranged. The reason why is because the word very strong is missing. Now on to gas, they have weak attractive forces, and they are in irregular pattern. So the reason why weak, the weakness causes to have irregular patterns here. Whereas if I have something that is strong, their pattern is something like this. But if I have something that is very strong, they are in a regular pattern, in a lattice structure. Okay, moving on for the motion. Particles of solid, they only vibrate. The word vibrate is very important. That means they are not able to go to any other position. But whereas for liquid, they slide across one another. That's the reason why. So because of the strong attractive forces in liquid, it's not as strong as that as solid. It causes them to slide across one another and not held in fixed position. Whereas for gas, they move about freely in all directions at high speed. Okay, so how we're going to explain about this, right? We need to always explain in terms of, this is the first thing that you explain. The forces causes the distance. So like for example in solid, the strong attractive forces causes the distance between particles to be very close. After which, then you talk about the motion, which they vibrate about in fixed position, and then on to the properties. So what do I mean by microscopic and macroscopic? This is the microscopic level. The forces is the microscopic view, and the properties are the macroscopic view. So this is the microscopic view means a small picture. The properties, it is the big picture. Okay. If not, we are moving on to the next page. Okay, the kinetic model of theory. This is the relationship between temperature and speed. Okay. Kinetic model of theory states that the kinetic model theory states that all matter is made up of tiny particles that make up matter, which are in continuous random motion. Okay, the word continuous random motion is a very important word, because this is actually called Brownian motion. Okay, you just need to remember that Brownian motion, they are just irregular movement. Okay, so as temperature rises, the average kinetic energy of the particle increases. The average kinetic energy of the particle increases. We have learned in the previous topic that kinetic energy formula is Ke equal to half mv squared. If my Ke were to increase and my mass remaining constant, this is a constant, it means that my velocity, my speed, have to also increase in order for my average kinetic energy to increase. So as temperature increase, the average kinetic energy of the particle increase, and the particle will move faster. Okay, moving on. Example 1, when a liquid is heated, okay, we'll do all the not correct answer first. So therefore, when a liquid is heated, the molecule does not expand. What do I mean by molecule expand? It means that the gap between particles do not expand. Okay, the molecules, okay, sorry, I'm so sorry, let's go back again. Okay, what does it mean by the molecule expand? It means that, let's say if I have a molecule, it does not become this size. Okay, the molecule gain energy. This is true because you gain heat energy. So therefore, B is technically a correct answer. For C, the molecule move faster. This is also true because I gain heat energy increases. It means that my Ke, average Ke increase. It also means that my speed increases. Okay, moving on. The molecules move further apart. So therefore, if I have two different molecules, when there is heat, it causes them to become further apart, but the size remain the same. So therefore, the only one that is not correct is A. Okay. I'll give you a bit more time. For example 2, using the kinetic theory of matter, explain why solids have definite shape and liquids do not have. As we mentioned before in the previous slide, we need to talk about the forces, followed by the distance, followed by the motion, then the properties. So how we do it, how we phrase it is one. The first point is say that forces of attraction of solid greater than liquid. This is the first point. Then you need to say that this causes solid particles to be held and vibrate about fixed position, while liquid particles are able to slide across one another. So I actually combine point number 2 and point number 3. So the last part, you need to say that hence solid have fixed shape and liquids do not have. So the way that we explain is like how we always say here. We always talk about the forces between particles, followed by the distance and then the motion. Then after that, I link to the answer. How they ask me how to explain the properties. Okay. Example number 3. Explain what happens to the molecules in water as temperature rises. The word temperature rise is very important. What do I think of when temperature rise? Number 1, temperature rise. It means that heat energy increases. And because heat energy increases, it means that average kinetic energy of molecules increases also. And because of this, you need to say the next point, which is since average Ke is equal to half mv squared, as Ke increases, this means that speed of molecule increases. Okay. This is the part whereby I explain using the kinetic model of theory. After that, they ask you to explain in terms of water. So you need to say that the speed of molecule increases. You need to explain that water movement increases. So therefore, the rate at which water molecules slide across one another increases. I'm explaining that the movement of particles increases, therefore the rate of sliding increases. Okay, so that's it for this chapter 7 on the kinetic model of theory. If you have any questions, please do feel free to give me any comments. Thank you.